Greetings, cosmic voyagers. Neil deGrasse Tyson here, and today we're diving deep into a question that tickles the very fabric of our existence. Did you know that our planet, this beautiful blue marble we call home, isn't spinning quite as fast as it used to? It's true! The Earth's rotation has actually slowed down by about 6 hours over the past 2,740 years. Now, that might not sound like much in the grand cosmic ballet, but it begs a rather dramatic question. What if Earth stopped spinning altogether? Imagine a world frozen in its tracks, a celestial pause button pressed on our daily lives. You probably remember from high school geography, or perhaps even earlier, that the Earth spins on its axis as it diligently revolves around our star, the Sun. This fundamental motion, this planetary pirouette, is responsible for the most basic rhythm of life, the cycle of day and night. It dictates when we wake, when we sleep, when the owls hoot, and when the roosters crow. It's a cosmic metronome that has ticked for billions of years, shaping life in ways we often take for granted. But what if that metronome suddenly fell silent? If you've ever gazed up at the stars or felt the warmth of the morning sun and wondered about the immense forces at play, then you're in the right place. Today, we're embarking on a thought experiment, a journey into the hypothetical, to explore the profound and frankly cataclysmic consequences if the Earth stood still. So, buckle up your curiosity, because we're about to unravel what would happen if our planet decided to take an eternal break. Stick around to find out. The universe is full of surprises. So why does our Earth spin in the first place? It's a question that takes us back to the very birth of our solar system, a story written in stardust and gravity. About 4.6 billion years ago, our cosmic neighborhood was a chaotic place, a vast, swirling cloud of gas and dust. Imagine an enormous ethereal nebula, pregnant with the potential for stars and planets. As this colossal cloud began to collapse under its own gravity, it didn't just fall inwards, it began to rotate. This is a fundamental principle in physics, the conservation of angular momentum. Think of an ice skater pulling their arms in to spin faster. The same principle applies, but on an unimaginably grander scale. As this primordial cloud contracted, it spun faster and faster, eventually flattening into a disk. At the center of this disk, the sun ignited, and further out, clumps of matter began to coalesce, forming the planets, including our very own Earth. The initial spin imparted to these nascent worlds during their formation has remarkably persisted. Once something is set in motion in the vacuum of space, it tends to stay in motion. There's virtually no air friction to slow it down, unlike objects here on Earth. So our planet has been spinning, a majestic cosmic ballet, ever since it was born from that ancient cloud. Picture a spinning top, a child's toy that whirls with mesmerizing stability. Now imagine that top never encountering the friction of the floor or the resistance of the air. It would, in theory, spin indefinitely. Our Earth is much like that super-powered spinning top. Unlike a spinning top in your hand, which eventually succumbs to friction and tumbles, the Earth doesn't experience significant friction in the near vacuum of space. There are some subtle forces, like the moon's tidal pull, that are gradually slowing us down, as I mentioned earlier, but for the most part, Earth has kept rotating with incredible fidelity for billions of years, a testament to the powerful forces that shaped our solar system. Now, we've established why Earth spins, but let's address the elephant in the cosmic room. Is it even possible for our planet to just stop? Could the daily rhythm of sunrise and sunset, a rhythm that has defined life for eons, come to a grinding halt? Well, from a purely astrophysical perspective, it's extraordinarily unlikely that the Earth will stop spinning altogether, at least not through any natural process currently underway or easily imaginable. The angular momentum of our planet is immense, a colossal amount of rotational energy. To bring such a massive object to a complete standstill would require an equally colossal intervention. Think about what it would take. This isn't like hitting the brakes on your car. We're talking about a planetary body with a mass of nearly 6 sextillion metric tons, spinning at speeds of up to 1,670 kilometers per hour at the equator. To halt this motion, the Earth would likely need to be hit by an object of comparable mass or energy, exerting an equal amount of force in the exact opposite direction of its rotation. Such a cataclysmic event, a cosmic billiard shot of unimaginable proportions, is thankfully not something we see on the horizon. Our solar system is a relatively stable place, all things considered. So while the Earth may continue its celestial pirouette for billions of years to come, perhaps slowing ever so gradually due to tidal forces, the scenario of a complete stop remains firmly in the realm of thought experiments. But that's precisely why it's so fascinating to explore. Science isn't just about what is. It's also about what could be, even if it's a wildly improbable could be. Exploring what could happen if our planet ever did halt its spin allows us to better appreciate the delicate balance of forces that make life on Earth possible. It's an exercise in cosmic curiosity, and that, my friends, is always an exciting journey. All right, let's suspend our disbelief for a moment and imagine the impossible has happened. Earth has stopped spinning on its axis. It still orbits the sun, mind you, but it no longer rotates. What's the first, most dramatic consequence? Can you imagine having 6 months of continuous, unrelenting sunshine? That's precisely what would happen to one half of our planet if Earth stopped spinning. The familiar, comforting rhythm of day and night, the 24-hour cycle we live by, would be utterly shattered. One side of the Earth would face the sun for half a year, while the other side would be plunged into an equally long period of darkness. With the Earth's rotation halted, the concept of a day as we know it would cease to exist. Instead, a single day would last an entire year, as the Earth completes one orbit around the sun. This means that for approximately 6 months, one hemisphere would be baked under constant solar radiation, while the opposite hemisphere would endure 6 months of frigid starlit night. Consequently, it would take up to half a year for the other end of the Earth, the side initially facing away from the sun, to finally see the sunrise. Imagine the implications for life, for agriculture, for everything. The temperature differences between the sunlit side and the dark side would become extreme. The days, or rather, the 6-month-long sun-facing period, would become incredibly, dangerously hotter, potentially boiling away oceans and scorching landscapes. Conversely, the 6-month nights would be far, far cooler than anything we experience now, plunging temperatures to cryogenic levels. This colossal temperature gradient between the two hemispheres would cause gigantic swirls of wind, atmospheric disturbances almost as large as whole planets, as the atmosphere desperately tries to redistribute heat. It would be a world of unimaginable weather extremes. Chapter 4. Cosmic Jet Lag. Your body clock thrown into chaos. Beyond the dramatic environmental shifts, what about us? What about the intricate biological machinery that makes us human? Did you know that your body, my body, every living creature's body that experiences day and night depends profoundly on the regular 24-hour schedule to set up its internal clock? This is known as the circadian rhythm, a finely tuned biological metronome that governs countless physiological processes. Anything that messes with this ancient, ingrained routine disrupts your rhythm, and a complete stop to Earth's rotation would be the ultimate disruption. If the Earth were to stand still, your entire sleep-wake cycle would lose its primary external cue, the rising and setting of the sun. You can think of it as the most extreme, extended jet lag imaginable, a perpetual state of temporal disorientation from which there's no recovery by simply adjusting to a new time zone. Our bodies are not designed for 6 months of continuous daylight, followed by 6 months of unending darkness. This fundamental alteration would throw our internal clocks into complete disarray, leading to chronic sleep deprivation on the day side and profound sleep disturbances on the night side. Long term, this disruption to our circadian rhythms would have severe consequences for our health. It's not just about feeling tired or awake at the wrong times. This internal clock influences a vast array of critical bodily functions. We're talking about hormone secretion, like melatonin for sleep, and cortisol for stress response, which would become completely dysregulated. Our energy metabolism, how our bodies process food and generate energy, would be significantly affected. Even our core body temperature regulation, which naturally fluctuates over a 24-hour period, would lose its vital rhythm, potentially leading to a cascade of health problems. Chapter 5. Shield Down. The vanishing magnetic field. There's another, perhaps less obvious but equally critical consequence of a non-spinning Earth: the loss of our planetary magnetic field. Deep within our planet, the Earth's core contains a vast amount of molten iron. The rotation of the Earth, coupled with convection currents in this liquid outer core, generates a powerful magnetic field through a process known as the dynamo effect. This magnetic field extends far out into space, forming the magnetosphere, which acts as an invisible shield, protecting us against damaging charged particles from the sun, the solar wind, and high-energy cosmic rays originating from outside our solar system. These harmful rays, streams of energetic particles, are constantly bombarding our planet. Thankfully, most of them are deflected by our magnetic field, guided towards the poles where they interact with the atmosphere, creating the beautiful ethereal displays we know as the southern and northern lights, the aurora australis and aurora borealis. You may have seen breathtaking photos or even witnessed these celestial ballets in person. They are a stunning visual reminder of the protective work our magnetic field does. If our planet stops spinning, the dynamo that generates this field would likely cease to function, and the protection of the magnetic field would be lost or at best severely weakened. Without this vital shield, these harmful solar and cosmic rays could penetrate our atmosphere and reach the Earth's surface in much greater quantities. This increased radiation exposure would pose a significant threat to life, potentially increasing rates of cancer and causing other severe health problems for humans and animals alike. Furthermore, the Earth's magnetic field plays a crucial role in navigation for many species, particularly migrating birds, sea turtles, and even some insects. They use it like an internal compass. Without this guidance system, these creatures could become hopelessly lost as they attempt to travel to their traditional breeding or feeding grounds, leading to devastating ecological consequences. Chapter 6. A Static Sky, the End of Celestial Motion. For millennia, humanity has looked up at the night sky with wonder, charting the movements of the stars, identifying constellations, and weaving stories around their celestial dance. One of the beautiful, almost meditative things about observing the night sky over time is how the constellations appear to change their position. They rise in the east, arc across the heavens, and set in the west, just like the sun and moon, and throughout the year, different constellations become visible as the Earth journeys around the sun. This celestial parade is a direct consequence of Earth's rotation and its orbit. Unfortunately, if the Earth were to stand still, if its daily pirouette ceased, you'd be looking at the same patch of sky each and every night, assuming you were on the dark side of the planet, of course. The stars themselves would still be in their distant positions, but their apparent motion across our sky, the motion driven by Earth's spin, would vanish. The constellations wouldn't be migrating across the sky from dusk till dawn. What you see when darkness falls would be what you see until 6 long months later, the sun finally begins to creep over the horizon for its half-year stay. Moreover, the seasonal change in constellations would also be altered, while the Earth would still be orbiting the sun, meaning different parts of the distant cosmos would be in our night sky view over the course of a year. The experience of watching them wheel overhead would be gone. The familiar patterns, like Orion marching across the winter sky or Scorpius heralding summer nights, would become static fixtures for incredibly long periods. The dynamic, ever-changing tapestry of the night sky, a source of inspiration and navigation for countless generations, would become a far more monotonous, unchanging vista. The universe would still be out there, but our perspective on its nightly show would be profoundly and perhaps sadly diminished. Chapter 7. The Great Slosh Water on the Move. Prepare for a truly mind-bending consequence of a stationary Earth, a radical redistribution of our planet's oceans. You might not realize it, but the Earth isn't a perfect sphere. Due to its rotation, it bulges slightly at the equator. In fact, the equator's diameter measures roughly 21.4 kilometers. That's about 13.30 miles, more than the diameter measured through the poles. This equatorial bulge didn't just happen overnight, it formed over billions of years as the Earth took shape and spun, a result of centrifugal force acting on its mass. The Earth's rotation has generated a persistent outward force, most pronounced at the equator, that has effectively moved solid matter and, crucially, vast amounts of water toward the planet's center line. This is why the water levels at the equator are, on average, up to 8 kilometers higher than they would be if there was no spin. It's like a subtle planet-wide swelling of the oceans around Earth's waist. Now imagine what happens if the Earth halts its spin. The centrifugal force that has maintained this equatorial water bulge for eons suddenly vanishes. With that force gone, gravity would take over completely, and water would begin to migrate away from the equator and towards the poles. The oceans would literally slosh towards the north and south, seeking a new equilibrium on a now non-rotating, more perfectly spherical Earth. The result? You could potentially walk around the equator without seeing much, if any, ocean water. The equatorial regions would become a vast, continuous band of land, a supercontinent girdling the Earth, separating two enormous polar oceans. Coastal cities would be submerged or left hundreds of miles inland, and the geography of our world would be redrawn in the most dramatic fashion imaginable. Outro our spinning home, a delicate cosmic balance. So we've journeyed through a rather extreme hypothetical scenario, haven't we? A world without spin. Truthfully, while the Earth's rotation has indeed slowed down over geological timescales, a tiny fraction of a second per year, this isn't causing significant catastrophic changes in our daily lives, nor is it heralding an imminent stop. The forces involved are gradual, and the energy bound up in Earth's spin is simply colossal. So, rest assured, our planet will continue its daily dance for eons to come. It's highly unlikely, bordering on the astronomically improbable, that the Earth will come to a complete stop anytime soon or ever, through natural processes. The cosmic collision required would be an event of such magnitude that a non-spinning Earth would be the least of our worries. So you can quit worrying about this particular doomsday scenario. Our planet is a remarkably stable and resilient system, finely tuned by the laws of physics to provide the conditions necessary for life as we know it. However, while a stationary Earth is a fascinating thought experiment, there are very real threats to our planet's delicate balance that demand our attention. What you can do, what we all do, is to look for the changes we can make to minimize climate change. This is not a hypothetical, it's a clear and present danger, a real threat to Earth's survival and the well-being of future generations. So let's channel our cosmic curiosity into a commitment to protect this spinning, vibrant